Morning, everyone. Myself, Monica Nansupriya, Assistant Professor in the Department of Electrical and Electronics Engineering. In this semester, I'm handling Basic Electrical and Electronics Engineering, subject code W25C01 in the regulation 2025. Today, we are going to learn about the logic gates, which are basic building blocks of all the digital electronic systems. Every digital device, such as the computers, mobile phones, washing machines, and traffic control system, uses the logic gates to make the decisions. So this logic gate is an electronic circuit that takes one or more binary input as 0 and 1 and produces single binary output. So the logic gate work with the binary numbers 0 is equals to low off, 1 is equals to high, that is on. That's a real life example. And the definition of the logic gate is it's a physical electronic device that performs a logical operation on one or more inputs and generate a, single logical output. This is the example of this is the definition of the logic gates. So the important term is a single input. There is a signal entering the gate and the output, the signal produced by the gate. And the logical operation is the decision-making process based on the Boolean algebra. If input is, for example, if input A for a NOT gate, the output is a 0. So the gate makes a logical decision based on the input. So the classification of logic gates is the basic gates, that is the basic logic gate, that is the OR, NOT, and AND. And the universal logic gates is NAND and NOR, and the special logic gate is XOR and XNOR. The basic gates, derived gates, that is the universal logic gates and the special logic gates. So first is the NOT logic gate. A NOT gate is called as the inverter because it reverses the input. So if the input is 1, then the output is 0. If the input is 0, the output is 1. So the NOT gate is the reverse input. The mathematical expression is y is equals to a dash, that is the a complement. So the real life example is the automatic emergency lamp. If power is available, the lamp is off. If power got failure, the lamp is on. This operation resembles a NOT gate. Next one is an AND gate. This AND gate produces the output 1 when all the inputs are 1. So if input is 1 and is it's a multiplication A B. So 0 into 0, 0. 0 into 1, 0. 1 into 0, 0. 1 into 1, 1. So if all the inputs are 1, the output is 1. That is the logical operation y is equal to A into B. So both conditions must be satisfied. For example, the real-time example is starting a car. Key is inserted. Brake is pressed. Only when both conditions are satisfied does the car start. So the AND gate act like a word AND. So the next one is an OR gate. The OR gate produces the output 1 if at least one input is 1. That is plus condition. 0 plus 0, 0. This is wrong. This is the OR NOR gate. We are having this bubble symbol in front of the OR gate. So it's a NOR gate. That is a complement of OR. So in OR, 0 plus 0 is 0. Here there is a bubble. So it gives 1. 0 plus 1 is 1. In the 0 plus 1 is 1. So we are having the 1. 1 plus 0, 1. So 1 plus 1, 0. So we are having the OR gate, that is y of a plus b. So only one condition needs to be true. So for a bus or bike. So this is the a real-time example of the OR gate. This is the NOR gate. So this is the NOR gate is in NOR gate y is equal to a plus b the whole dash. First perform the OR operation, then invert the result. First OR means plus. Okay. So 0 plus 0, 0. Complement is 1. 0 plus 1 is 1. The complement is 0. 1 plus 0 is 1. The complement is 0. 1 plus 1 is 1. The complement is 0. So this is the NOR logic gate. This NOR produces a high output when all inputs are low. So NOR gate is called the universal gate because any logic circuit can be built only the NOR gates. So the alarm remains silent unless any sensor becomes active. So this is the example. Next one is the fundamental of Boolean identity. Is a Boolean algebra was developed by the George Boole. Is introduced used to simplify the digital circuit. The simplification of reduces hardware, reduces cost, reduces power consumption, and improves the speed. So we have the first commutative property. In this addition, a plus b is equals to b plus a. And for the multiplication, a dot b equal to b dot a. So the meaning is change in order does not affect the result. So 2 plus 3 is equal to 3 plus 2. So that is the meaning. Next one is the associative property. A plus b of plus c is equals to a plus of b plus c. Next, a dot b of dot c is equals to a dot of b dot c. So the grouping can be changed, so it does not affect the result. Next one is the distributive property. So a of b plus c is equals to ab plus ac. This is the result. Okay, so similar to the ordinary algebra. So same concepts applied in the Boolean laws is that idempotent law is that a plus a is equals to a and a dot a is equals to a. Repeating a variable does not change the result. So absorption law is a plus ab equal to a. A dot a plus b is equals to also a. Extra term becomes unnecessary. So it used extensively for the simplification. Next one is the complement law. A plus a dash is equals to 1 and a dash is equals to 0. So a variable and its complement always produce a fixed results. So a is a equal to 1, a dash equal to 0. So these are the rules of the Boolean algebra. The a plus 0 equal to a. This is the identity law. A plus 1 is equals to 1 and a dot 0 is equal to 0 and a dot 1 is equal to 1, a plus a equal to a. So these are the key rules: identity law, null law, complement law, idempotent law, absorption law, distributive law, associative law, commutative law. So without Boolean algebra, digital circuit design would be very difficult. So the computer design, mobile phone, embedded system, robotics, so all we are used is the Boolean algebra. So this is some circuit simplification using the Boolean algebra. So AB plus A of B plus C plus B of B plus C. So we are writing AB. We are inserting the A to the this adding component AB plus EC plus BB plus BC. So AB, AC, next BC. Here the BB and AB is written as B. So the AB and B is written as B. There is no extra exemplary component. So AC. So B plus AC is the answer. So we have seen about the basics of logic gates and fundamentals of Boolean algebra and the laws of Boolean algebra. We have discussed this session. These are the references, and we will discuss the next topic in the next class. Thank you.